So I started, I think John had set up the project to use Gulp, which was quite nice because it had the documentation generation, all that stuff already done. But actually for the sort of like the quick iteration of actually developing the thing, I actually ended up just using Pulp, which has been really nice because you can set things up to watch your code and whatnot. But then, when I actually want to bundle a thing, I'll just run Gulp, and I've modified the Gulp file slightly to modify the way the documentation is generated, modify to add a example project in here. So if I open the example, okay, so this is a slight. I just want to change something slightly in here. Which I should have done in the repo really, but this needs to be monospace to really make it clear what's going on. Okay, okay, so you can just type Markdown in here. It's a header, and obviously the HTML gets rendered over here, and I'll go through the code and show how that works. Okay, so you can type paragraphs, graph 1, and you can do with you can add spaces like this, or you can add, for example, soft breaks by adding two spaces here. If it's fewer than 2 spaces, the spec says it has to be just a regular space character. If there's 2, it turns it into essentially a BR. These are line breaks. Obviously, when you have a blank line, so you can do inline things. You can say here is some code and auto link and manual link. So then this becomes a link to purescript.org. Image. Can I remember the? Yes, no, can't remember. Something like this. But you can embed images like this. You can do things like full text. So you get all the usual inline stuff, and then you can do block quotes. You can do lists. List item 1, 2, 3. You can nest lists. 1, 2. These can be numbered. Okay, so all the usual stuff, right? And then there's a couple of extensions that John had wanted in this fork of Markdown called Slamdown. The first one is executable inline code. So I could say something like, here is some PureScript code. Trace hello world. And then I can actually make that executable by putting a bang character on the front. And in the AST, this is actually represented differently, so that this could be walked via a traversal and actually executed and replaced with the evaluated, the result. So you'd say hello world. And then you can actually do the same with inline code. So you can put a bang on the front of inline code and it'll do the same. And the HTML rendering doesn't show anything different, but again in the AST it shows up slightly differently. Okay, and the second modification is custom forms. So you can build forms by, let me see if I can remember how to do this. So you can say, for example, name is, and then you can represent a text box like this, for example. And you put the default value in parens. And you can say gender, you can do radio buttons. The first one is selected, you put an X in the parens, let's say male. And the other ones don't have anything in the parens. That turns into radio buttons. You do checkboxes. What was the other thing? Okay, so we can say, for example, state. So if we can remember the syntax for this, I think it looks like this. Yeah. Okay, so that becomes a drop down. You can put multiple options in here.
Cool.
What else was there in the spec? Oh yeah, required field. So you can make something required, and it basically just persists the star here, but there's a boolean in the AST. I think if there's anything else. Well, but anyway, so basically you can build these forms like this, and you get this sort of AST representation of the form that you can turn into HTML or do whatever else you want to do with it. Oh yeah, checkboxes. Sorry. I don't know. Employed. Oh, let's say status is employed. That's a really bad example. But you can sort of build checkboxes like this. I think if you put an X, yeah, so it checks the box if you put an X in there. Or let's say full-time contract. Other slight issue here. Oh, I think these have to only be, yeah, that has to be, these have to be single words. Okay, so that's an overview of what it does, and I'll go over the code. So we look in the source folder, text, Markdown, Slamdown. Okay, so it's broken up into, there is, actually the types are defined in the Slamdown module, so that's this one. Okay, so it's really simple. The AST for the Slamdown document type is just a list of blocks, and then there's two types that we're interested in. So we have various instances for these things. There's show, compare, and equals, and the equals and odd instances are really lazy. They basically just defer to the underlying show instance, so we just compare the strings. You can use a monoid to join together different documents. But then the two types we're interested in are block and inline. So block represents block level elements as defined by the spec, so things like paragraphs, headers, block quotes, lists, and you can nest blocks inside other blocks, like inside lists. You can have other blocks, inside block quotes you can have other blocks. Yeah, I guess I forgot to show link references, so we support link references as well. And then inline elements are things that you would embed inside a paragraph, for example. So that includes things like strings, entities, entities, things like you expect from the HTML, where you want to embed symbols using the notation we'd use in HTML. So those are entities, various types of spaces and breaks, emphasis, bold, embedded code, links, and all the form fields that I just went over. So the form field type just enumerates the different types of forms different types of form elements we can have. Okay, so then this doesn't have anything particularly interesting in it apart from the instances and the types, apart from this method everywhere, which is used to perform traversals on the code, on the document. So so you can do fairly general things with this. So this says, if you give me a function that transforms block level things, and a function which transforms inline level things, then I'll give you a function that does this on every part of the document all the way down the tree. If you give me a Slamdown document, I'll transform it into a new one. And that's particularly useful if you want to define an evaluation function. So I mentioned we have this idea of executable code. So we separate in the AST up here, instead of just having a string inside an inline code block, we have a boolean to tell us whether it's executable or not. So that's essentially whether we had that bang symbol in there. And then the code block type in the case of a block level piece of code is either a fenced piece of code or an indented piece of code. And if it's fenced, then again we have a boolean, tells you whether it's executable. So in both of those cases, if we have a fenced piece of code or an inline piece of code with one of those flags set to true, then we can use this user-defined evaluation function to go inside those code blocks all the way through the tree and evaluate the code based on whatever the user says that type of code should evaluate to. So you can do other things with this. You could do something that, for example, changed all the headers to one level lower, so that if you wanted to embed a document inside another document, for example, you didn't mess up the header levels. So this is pretty generic. Okay, so then slightly more interesting things are in the 3 modules, parser, pretty, and HTML. So parser is parsec style parsing for parsing the AST. Pretty is just a string pretty printer, and HTML is the HTML renderer. Okay, so the parser is really kind of straightforward. It's just kind of a lot of fairly mundane code, but it uses this intermediate representation called container, and this is sort of inspired from a library called Cheapskate by John McFarlane. So container looks a lot like block level elements, but it doesn't quite contain the same type of information. It's basically, like, say, an intermediate representation of the document in the middle of the parse. But it has a lot of the same type of constructors like text, headers, block quotes, list items, code blocks. And then if you look through this, it's, like I say, it's all fairly straightforward stuff. There's a lot of small functions. I should probably use like where clauses to break these up. And it's all sort of string manipulation, so it's pretty level, low-level string manipulation. And I suspect quite a lot of this could be improved by not using explicit recursion and using regexes a little better. So I use them a little bit, but not nearly as much as I could. So there's not really a lot that's interesting to say here. This is basically like sort of doing things like finding spaces and taking spans of various bits of text that match criteria. So let's take an example. We'll look at list. So the first step is to parse the containers. So we go through all these cases, we try and figure out which one it is. For example, so if we find that something is a list item line, then we call this split list item function to split out this object with these various types. So we get the type, the items that comprise the list, and the other lines. We recursively call parse containers to parse all the individual blocks inside the list item. We add it to the accumulator. So I'll just dig into that as one example. So to test whether something is a list item line, so various things here correspond to things from the spec. So we start by removing this concept of non-indenting spaces, which basically corresponds to 3 or fewer spaces on the front of a line. And then we test if something is bulleted, if it's a bulleted list line or it's an ordered list line. If it's bulleted, if we take the first character from the string and it is a bullet character, so it's one of these. And let's see what this is. Oh, okay, and there's a part of the spec that says that the leading spaces between the bullet and the text have to be fewer than 5 spaces long. And something's an ordered list marker if it comprises several digits followed by either a period symbol or a right paren. And then again we test the leading spaces. And then the last one was the split list item function, which takes a list of strings, which is lines, and gives us this object that tells us about the strings around that list. So we remove the non-indenting spaces. We use the span function, which is from the purescript-arrays library, to basically take the maximum prefix of this set of strings that is indented to the right amount for this type of list item. So we scan the strings to see when the indentation stops being appropriate to be sort of nested inside the list item. And then we sort of recursively, we're going to get this list of lines that comprise those that list item. We're going to recurse on these strings. And then the other lines are basically everything that was on the other side of the span. So span basically splits a list into two parts called inits for the things that do satisfy whatever filter you pass in, and rest, which is everything else. So everything else is basically exactly the same as that. So we pass the containers, and then there's just a tidying pass called parse blocks, and that goes through a list of containers and turns it into a list of blocks. So that does things like, for example, bundling up neighboring list items into a list. And then the other part is this parse inlines function. So this is where we use the parse-xdel parsing from the purescript parsing library, and that's defined in parser inlines. And this is fairly straightforward stuff. It's basically just regular parse-xdel parsing, just straight out of the spec, with a couple of simplifications, like I mentioned. There's a couple of things that we don't parse, like we don't put labels on links, we don't put labels on images, but it's it's fairly straightforward. We match sort of identifying strings, and then we use a lot of the standard combinators: many till, optional, option maybe, and that's about it for the parser. Trying to think if there's anything interesting to say about this, but I don't think so. Yeah. So any questions on that? Or any of that stuff? Oops. Okay, good. People are still online. Just wanted to check. Yeah. So then the other sort of part of the application is the HTML renderer, which again, it's it's pretty straightforward. It's just a regular top-down traversal of the AST. There's this intermediate representation of a HTML document, or portions of a HTML document. So a document can be either text, and it's the string represents the text that's contained in this part of the document, or it can be an open tag with a name and a list of attributes, and a bunch of children elements, or it can be a closed tag, and it turns out that I don't need to bother with attributes in this case, in the cases where I use closed elements. An attribute is just a pair of an attribute name and an attribute value as a string. And then to turn Markdown into HTML, we parse the Markdown, which is what we just looked at, and we call this toHTML function, which creates one of these things, and then we call the render HTML function for every piece of HTML we get and glue them all together with folder map. So render HTML is really simple. For text, we just preserve the text. For open elements, we render the opening tag, we render the things inside, we render the closing tag, like this. And for closed tags, we just do the obvious thing, just put some angle brackets around the tag. And then the interesting code is in the toHTML function. So this takes a slamdown document and turns it into a list of HTML blocks. And it's it's just a fairly routine traversal of the AST. So for paragraphs we create paragraph elements, for headers we create header elements, etc. all the way down. So there's probably some improvements that we could do here. I think the spec for the most part has suggestions for what you're supposed to actually create in terms of HTML. There'll be a couple of things here where I don't do the exact same thing, but I think for the most part this is pretty close to the spec. This is obviously new stuff, rendering form elements. But again, it's pretty straightforward. The obvious thing, text box just gets turned into input fields. Same with radio buttons, checkboxes, etc. Okay, so then the only other sort of interesting thing that I want to show is the test suite, which is kind of neat. So I started off with these. So I have this test document function, takes a slamdown document and basically tries to pretty print it and then parse it back and make sure that you got the same document you started with. And then I just pass in a bunch of dummy documents just to make sure these all these all pass to the right thing. we have some examples of forms and things as well. Okay, so then it'll say all the static tests passed if we got this far. And then the next thing it does is generate some random documents using the the strong check library. So there's a generator at the bottom of this file that tells you how to generate an arbitrary document. So it just prints them out so that you can get some examples of the sort of tests we're running. And then it generates 1,000 random documents and tries the same test that it did up here. So tries to pretty print and then parse. Make sure you get the same thing you started with. So the generator's pretty. I mean, you have to make some restrictions because obviously not every. There are certain examples where what you parse, you sort of expect that you would parse to something slightly different. So, for example, if you stick, there's a small bug in the pretty printer, for example, where if you have two block quotes next to each other, they'll get merged into the same block quote in the pretty printed output. So because I know that's a bug that I haven't dealt with yet, I don't bother generating those types of documents. I limit myself to a single block quote in a document. But as various bugs get fixed and corner cases get handled, we can expand this test suite so that we generate like more and more different types of documents. And hopefully at some point, the AST will be completely faithful to all the documents we support. We should be able to support everything. So then you can say things like, hopefully this should sort of read like a spec of how you generate things. We say that a block is one of these things. It's either a small array of this block 0, which is basically a simple type of block, or it's one block quote, or it's one list, or it's one code block. And block 0 is one of these things. It's a paragraph with some kind of inlines inside it. That's shown in a sec. It's either that or a header. We can choose a header from 1 to 6 and put some simple text inside it. We can generate a code block that's a fenced code block that's either evaluated or not, with some randomly selected alphanumeric info string, and then a small array of alphanumeric strings going inside the code block. Or it's a link reference with some randomly generated strings as arguments, or it's a ruler. And then these construct things like list items and block quotes. So for example, we can generate a list. It's either bulleted or ordered, randomly selected, and then inside we have a tiny array of tiny arrays of simple blocks. So this is another restriction, that we don't want lists inside lists in our test suite. So that's probably, I know that lists inside lists generally work, but I wanted to keep the test suite as simple as possible and just get things working. So I put some restrictions on the code, on the test suite to only generate some simple things. And maybe it's a little too simple right now. Okay, and then same thing. So here's how we generate inlines. The inlines are either the simple inlines, which are called inline 0, or it's a link, or it's a form field. So just to be clear, so this the reason I have this separated inline 0, there's something similar in the parser, and the reason is there's actually precedence rules defined in the spec that say things like tell you how links interact with embedded code blocks, for example. And there's other rules that tell you that you can't have particular types of inlines inside other inlines. So you can't have links inside links. So it's important that I generate that a link, for example, contains an inline 0, and it doesn't contain an inline, because otherwise I would be able to generate links inside links. But this is all basically the same stuff. So we just basically mirror the AST. We generate one. We create one generator for every constructor. We glue them all together with the alternative combinator one of. That's about it. And then we just have these very simple generators that generate things like strings. But then if we, let's see, I can say I think it's gulp test. So it'll take a little while, but when it's done, what it'll print out obviously is those static documents. And I forget if it shows the Markdown or not, so you can see what it's actually parsing, but then it'll give us a bunch of sample documents that it generated. and then it'll do the 1000 test suite, the 1000 random tests as well. Last time I ran this, it took about 12 seconds, so it should be finishing. There we go. Okay, yeah. So here are the ASTs for the various static documents that I created, and then here it generates some random documents. So here's one it generated that contained. Actually, I should put some spaces in here. I don't really know where the boundaries are, but let's just assume, for example, this is a document. It generated one with a text box that takes a date time. It generated one with a list, and then it ran the random test suite. So yeah, we know that 1000 out of 1000 random documents passed the test with the parser and the pretty printer being compatible. So that's good. So yeah, I guess that's the overview. Does anyone have any questions about the code or any part of that?
I just wanted to say that it looks a lot cleaner than some of the JS Markdown implementations.
Oh really? Yeah. I mean, it's pretty slow. That's the only. I mean, you know, you can actually just take the one of the neat things is you can take the README for the actual repo and just paste it in here, and it'll actually render the right thing in here. It just looks like GitHub, but it's really slow, so it'll take like 2 seconds to render it. But there's a lot of really sort of obvious optimizations. So what I'd really like, if people are interested, is to kind of iterate on this a little bit and optimize the things that are really obvious, like don't do explicit recursion. I did explicit recursion because I wanted to get things working and it's easy, but we should be using folds and scans and map accumulator functions and all that kind of stuff. And then use regexes where we can in the inline tests and all that kind of stuff. And I think it could actually become pretty fast. I think it'd be really nice to have like it might not be sort of a reference implementation of common Markdown because I cut too many corners, but maybe it could become that one day. But even if it's not, it'd be nice to have like something like that written in PureScript. I think that was like a nice example of something practical. Not to say we don't have other practical things, but yeah. But I don't know if people are interested in working on something like that, but I think it could be kind of useful. And I like the I think it's a nice fit. The traversals, the code evaluation and the approach with like traversals and stuff, I think is like a really nice fit for like a pure functional language. I have some ideas for like stuff I might end up doing with like the form field stuff. So it'd be interesting to see if people use it for anything anyway.
Cool.
I think I already found some things that really could be improved.
Mm-hmm.
Decomposing arrays for head and tail.
Right.
Is the worst thing like that
Mm-hmm.
one can do for performance.
Yeah, it's really slow. I mean, it basically it's like a recipe for an instant sort of quadratic blow up in complexity. So yeah, there's definitely a lot of optimization opportunities. So yeah, there's definitely
because it's so easy to do in PureScript. Like,
what's that, sorry?
because it's so easy to do that mistake in PureScript with the arrays.
Right.
Because,
well, I mean, the other possible fix is that we just turn all the arrays into lists. Use the list library. That's definitely an option too. I mean, most of the there's no sort of random access, right? Everything is either we construct things linearly end to end. We deconstruct things as folds. So yeah, I could use the list library as well. That could be kind of a neat solution. The only nice thing, I guess, about using the array library, the arrays library and the array data structure is that you could potentially use it from JavaScript as well that way. Although I suppose everything's an algebraic data type. The block and the inline constructors are algebraic data types, so yeah, that could get messy. But I guess as long as like the parsing functions and the pretty printing function and all that kind of stuff have relatively simple types, then you could use that stuff from JavaScript and it'd still be kind of useful. Maybe like the everywhere function or something.